In this video, we will look at flux integrals of vector fields on parametric surfaces. So let's review the setting. In the following, we will denote a parametric surface as S with the parametrization given by R of u comma v, with the parameters u and v coming from the domain D. And this S is the parametric surface that we will be working with. When that is the case, the following structure, capital N, defined as the cross product of R sub u, namely the partial derivative of the parametric surface R with respect to u, with R sub v divided by its own magnitude, is called the unit normal vector field, aka the orientation of the parametric surface S. So geometrically speaking, if we illustrate the parametric surface S as this surface in the space, then roughly speaking, capital N is going to be a vector that is normal to the parametric surface. And at different point, the unit's normal vector may be pointing towards a slightly different direction, but they are all going to be orthogonal to a parametric surface. And when this is the case, we will be defining the flux integral of a vector field. So let's denote a capital F of x comma y comma z be a vector field. Then we could talk about the flux integral of this vector field on the surface, which is denoted as F dot product with your capital N ds. So that will be the notation for the flux integral of this vector field. And according to the surface integral, this flux integral could be converted into a double integral by the following transformation. First, we're going to evaluate the vector field capital F on the parametric surface. Namely, we're going to plug the parametrization into the variables of this vector field. And we're going to write up the more explicit expression of your capital N, which was given by R sub u cross R sub v divided by its magnitude. On the other hand, we recall that ds is in fact replaced by the magnitude of R sub u cross R sub v dA. So those two magnitudes are going to be canceling each other, so that what we're left with, that's going to be the double integral of capital F of R of of u comma v dot product with just the cross product between r sub u and r sub v. So that would be the formula that we're going to be using in computing the flux integral of a vector field over a parametric surface.